Hello everyone, this is Yogesh. So today my topic about smoothing an image. So basically, if you are taking about image filter, there is a three domains. One is a spatial domain, and another is a frequency domain, and another one is a combination domain. Combination domain is nothing but it's combination of spatial and frequency domain. So and also spatial domain working with only a pixel values, but frequency domain is working with the image Fourier transforms values, and it converts one and it converts into inverse transforms and gives the output in a spatial domain wise. So after that, if you are going to taking on this is my topic, introduce a Gaussian noise and speckle noise over image, and after that image enhancement using spatial domain filters and comparing average and median filter, and last one is a sharpen an image using high pass filter in frequency domain. So first, if we are taking the introduce Gaussian noise and speckle noise over me. So this is our packages that what we need to import. So I'm just going to import this packages. So after that, here I'm done Gaussian noise and speckle noise. So first of all, I just giving the figure size, and after that I'm reading that image, so wp.jpg, that's my name, and the 0 mentions the gray mode, and if you use 1 it's comes under the color mode. So after that, this is a random noise of, I'm just giving the mode, what mode we are going to be using. It's Gaussian, speckle, salt and pepper. So what's that? So after that, so I'm adding a subplot one. So here I'm going to place three images. So one is a original image, and next one is a Gaussian, and next one is a speckle. So I'm just off the plot axis. So I'm just going to, so I'm just run this code. So this is our output. This is the original image, and this is a Gaussian image, and this is a speckle image. So if for example, if I give one, so it will use in color mode this images. So this is the color mode. So after that, image enhancement using spatial domain filters. Yeah, this is nothing but basically spatial domain filters working with the coordinates of pixels within an image. So if we are taking this image enhancement, we are working with smoothing, sharpening, and also histogram equalization. So we are going to be looking about smoothing and sharpening. Here we are just looking about the equalization. So I'm just read the image and giving a gray mode, and just read the image in a equalize hist package using the equalize hist package. So I'm just using that to create histograms equalization. So I'm just stacking the images in a vertical side, and just I'm going to run this code, and it shows like us. So, and this is the one, and after that program to comparing averaging and median filter. So averaging filter is nothing but it's just a technique to it's just average filter is a technique to average the pixels under the kernel area and replace the central element, and replacing the central element. So we are going to taking, if we are taking the 3 into 3 cross matrix, so we are taking the whole numbers and average it and place into the central element, and placed into the central element. So this is the syntax for averaging filter. So we can using Gaussian filter, box filter, anything. So for an example, this is a box filter. So we need to give source of the image, and after that kernel size. Kernel size should be in odd number because it comes under one. For an example, it comes 1 comma 1 3 comma 3 5 comma y, and also it's only up to range of 31. So if we give 33 35, it shows the error. So this is the x coordinates and y coordinates, and this is the destination of the image, and this is the border type. So we are using the border default type. So I'm just read the image. After that, I'm giving a Gaussian blur. Here I'm using the Gaussian blur, and this is the source of the image, and this is the kernel size, and this is the border type. Here I'm using the horizontal stack to work. So I'm using a horizontal stack So this is the image. This is my original image and this is my destination image. So I'm going to run this. So here this is my destination image using the Gaussian blur. So it has some blur here. So after that using the box filter, so this is also like that. We are giving the depth. Instead of the Gaussian filter, we are using the box filter. Here we are using some parameters in the box filters called depth, anchor, and normalize. Depth it's depth, anchor, and normalize. And just once again read the image and giving the kernel size and read it. And this is also I'm using a horizontal stack, so I'm going to run this. So what? Oh, it's already opened. Wait a minute. Yeah, okay. Just a minute, guys. So interrupt the kernel. So once again I run this. This can't be works. Kernel restart. So yeah. Here this is my box filtered image. We run this once wait a minute. So after that here we are using the medium filter. So medium filter comes under the non-linear filtering. So we are having a linear and non-linear filter. So linear filtering is working with the neighboring, averaging the neighboring pixels, but non-linear filtering, it's mainly about the order statistics like minimum, maximum, median, like that. So we are just this is the syntax of so we are giving the image and kernel size only. We are just only to replace the central element using the medium or max or minimum using this filtration median filter, minimum filter, or maximum filter. So using that here, so that's so that's the thing. I'm just reading the image and also I'm giving kernel size and you're using the horizontal stack. So this is the image, original image and the destination image. So I'm going to run this. Wait a minute, I'm just getting. Ooh, okay. Yeah, this is my median filter image. So friends. So next thing is the sharpening an image using high pass filter and frequency domain. So basically a low pass filter and high pass filter. Low pass filters, sorry guys. So just a minute. Yeah, okay. And now here, so we are just giving some now we are going to looking about sharpening an image using high pass filter and basically low pass filter and high pass filter. High pass filter we are working with only a sharpening an image and the low pass filter working with we will working with only a smoothing of an image. Just smoothing it's going to be blurring the image in the surface area, but sharpening it's only working with corner or edges in the image. So I'm just giving a function name called main. So after that I'm just reading the image and after that I'm giving a CVT color of so BGR to RGB. So so just yeah, BGR to RGB. So I'm changing my color into BGR mode to RGB. After that I'm just giving a Laplacian. So here sharpening an image using. So here I used the Laplacian one and after that I'm used the Sobel. So I am giving the source of the image and kernel size and scaling. So border type too. So after that, so I'm just giving original image and the just original image and the destination image using this the for loop. So I'm just going to plot the two images. One is the original and one is the um, destination image. So I'm going to run this. So this is my original image and this is my output image using the Laplacian. So this is only I'm working with the and this is Laplacian and this is going to be Sobel. So we can use the here this go and this one I'm just using the I'm just not so I'm not mentioning here any x-axis or y-axis like, but here I'm mentioning under working with the x-axis and y-axis. So this is the just I'm reading the image and converting the BG to RGB, and I'm just using a Sobel filter, and this is the source of the image. So I'm going to work with under the x-axis and under the y-axis. So this is the x-axis and this is y-axis, and this is the kernel size and border type too. So and this one is working with the x-axis and y-axis. This is a combination of x-axis and y-axis. So here we are going to look for the four output images like original and working with x-axis, working with y-axis, and combination of that. So here I'm giving the range of 4 because I'm applying the 4 images. So plotting the subplot the image and showing, so gives title and x label, y label. So I'm just run this code, and what will our output? Yeah, this is, so this is works under the x-axis, and this is under works under the x-axis. This is under works the y-axis. So we can look here. So we have only have vertical lines, and here we are having the horizontal lines. This is the both combination of vertical and horizontal. So this is the original image. So this is my presentation about smoothing an image using Gaussian noise, speckle noise, and salt and pepper. So spatial domain filters, averaging the filter, averaging and median filter. So this is all. So thank you.